For the past few weeks, we've been talking a lot about waves, and we've talked about how waves are disturbances, they carry energy, and the first type of wave we really kind of talked a lot about were sound waves, and how sound waves can carry information through the air to our ears, which then takes a signal to our brains and let us know what it is we've heard. Sound waves, remember, are longitudinal, they are mechanical, they require a medium to travel through. Another kind of wave group that we talked about last week a lot were electromagnetic waves. And electromagnetic waves were different because they did not need a medium. They could travel through outer space. They have kind of more freedom in that sense. There's also certain amount of electromagnetic waves that we can sense. We can see the colors, but there are all these different waves out there that we can't see. And they're all different forms of light. They all come from the sun, they come from stars, but we can only sense a certain part. Just like with sound, we can only hear certain frequencies. And those things that are beyond, either above or below, our range of sensing are still there, and there are even other animals that can sense them. Well, all of these different waves, whether they were sound or light, these all carry different kinds of information. And that's, in a sense, what waves do, is they carry information. They let us know about the world around us. They let us know what's going on. Okay. So today we're going to talk about how all of these different waves, whether they're sound, light, what have you, can be grouped into kind of two different categories. We've got, and I'll start at the beginning here, analog, and we have digital. And these are two different types of signals, and they have different sets of advantages and disadvantages. So before we go into like more of the examples, let's talk a little bit about what they are. Okay, so what do these things have in common? Analog and digital signals both are used to transmit information, usually through electronic signals. Okay, this is what they have in common. They are both transmitting information. And they both do it usually electronically. However, there are times when it's not. Okay, so this is what they have in common. Now, here's how they differ. With analog, when we're sending information, you vary the amplitude of the pulses. Remember, amplitude is the wave height, and those analog signal waves are very smooth. So like here on this top picture, notice how the analog signal is a smooth signal. Okay. Now with digital signals, the information only has two amplitudes. Okay, so like here, you could have the amplitude could be here, here, here. I mean, there's all different kind of locations here. But with digital, it's either up or down. There really is no in between. Okay, so that's what it means, only two distinct amplitudes. So again, up here the waves are nice and smooth and flowing, and down here they're square, basically. So another way they differ is that analog, the data is more exact. So for example, if this is an original sound wave, so maybe this is a sound wave from when Miss Leach was playing her clarinet, and it was a beautiful sound wave, wonderful, and then we have to take that sound wave and we have to convert it. And let's say we're going to look at it through an analog lens. Well, looking at it through an analog lens, the wave is basically the same. It's a more exact to its original form. Well, if we take that same original sound wave and we try to put it into a digital format, like let's say we want to put it on the computer and things on a computer have to be digital, this is what that same sound wave is going to look like. It's an approximation or an estimation of what the original sound wave was, but it's not exactly the same. So you have all these little different ridges right here. It's not quite so smooth. Remember the other slide we talked about how analog were nice and smooth and digital were more rigid? Well, that's exactly what we're seeing here. This analog is nice and smooth sound. The digital is more rigid. Okay. A few more pros and cons here. With analog, the data is linear. So that means that if you start playing something, you have to keep going from start to finish. Digital, it's nonlinear. That means it can be played back at any point. Kind of like, and we'll talk about this more later, like if you're watching a DVD versus a VHS. A DVD, we can skip forward to different chapters, you can skip scenes, and it's really easy. But with a VHS, you have to actually hit the fast forward button, and it fast forwards, and then you have to hit the rewind button. And the most annoying part of all, when you're all done, you have to rewind the entire tape. It takes forever. It's really annoying. And so that's where digital is different. We don't have to wait for that anymore. Analog, the data is a lot higher quality. And you can see that looking back here, the quality of the sound wave is much better in analog versus digital. The problem is, if we have analog data, it wears out after a while. And we'll show you with some of the technology that I have. Whereas digital, it's pretty solid. It's not going to wear out. You're not going to lose that information. Analog, we can't store as much data. Digital, we can store a lot more. Analog, the technology that uses analog signals is a lot cheaper, whereas with digital, the technology is way more expensive. All right, now what I would like to do is show you a video here about analog and digital differences.
Almost every day we hear about things being described as analog or as digital. It's kind of like the difference between men and women. No, wait, this is the wrong channel for that. Instead, it's like old cell phones, which used to be analog, but now they're all digital. At this point, most countries have either changed or are in the process of changing their television transmissions from analog to digital as well. Ah heck, even clocks can be analog or digital. Let's use these clocks to learn the difference between analog and digital electronic signals. Even though there are only 12 numbers on the face of this clock, you can always tell how many minutes have elapsed just by looking at how far the minute hand is between the two numbers. When we look at a digital clock, all it can do is show us, for each digit of the time, the numbers 0 through 9. Even if we zoom in really close, we can't see how close the clock is to flipping to the next digit. So this means the increments of time are fixed to certain digits or levels. Okay. I know you're asking me, how does this all apply to electronics? Let's use this to talk about analog electronics first. So we got to go back to the analog clock. As the clock's hands sweep across its face, the time displayed is continuously updated with nearly infinite precision. The key here is the continuous change. Analog signals are signals that are continuously variable, or, in other words, continuously changing, just like the time on the clock. As we learned in the video on the difference between AC and DC, the AC voltage in your house continuously changes at a rate of 50 to 60 Hertz. Imagine that we had the ability to stop time and look at the voltage. Okay, I know, Bad pun, but what I wanted to show here is that as we move across in time, that the voltage value is constantly changing. This doesn't mean that analog is only found in the wall sockets or through AC, it's just a very good example. In fact, there are sensors, like this accelerometer, which provides an analog output. This sensor varies its output voltage depending on how much acceleration is occurring. If you want to use that analog voltage with a digital system like an Arduino, then you're going to need to convert that signal to digital first. Going back to the digital clock, remember that time can only be represented by fixed number of symbols like 0 through 9. The same thing is true in digital electronics. The digital signals can only be represented with fixed symbols like 0 and 1. But how do you get those zeros and ones? Well, it turns out that they're formed from voltage. Digital signals can have both a high level and a low level. And so what this means is that at 0 volts, the signal is considered a digital 0, and then at some high voltage, say like 5 volts, the signal is considered a digital 1. As it turns out, digital isn't quite this absolute. Depending on the transistor technology being used, there is a range that the signal might be considered a 0 or 1. For example, on this Arduino Uno, a digital 0 is considered 0 volts up to 0.5 volts, while a digital 1 is anywhere from 3.5 volts up to 5 volts. And so there's these two bands where there's the low and the high. The area between the low and the high is an undefined area. A digital signal with a voltage in this zone could either be considered a 0 or a 1. Because digital logic needs to have a value associated with it, this undefined region will get turned into ones or zeros. Problem is, we can't always predict which one that they will be. The key to understanding the difference between analog and digital is to remember that analog voltages continuously change, while digital voltages have defined levels. When you step back and think about it, it kind of turns out that digital signals are actually analog signals where the voltage levels have special meanings.
Okay, so what I want you guys kind of to get from this,
Digital signals are actually analog.
pause, is that analog signals, it doesn't have to be just black and white. It's more of a gray area as far as what the output is. Whereas in digital, everything is either ones and zeros. It's on or it's off. It's yes or it's no. It's black or it's white. And so things have to be very exact. Going back to that one slide that I showed you guys back here, you know, we can go up and down and up and down and it's curved and smooth, whereas with digital, it's either on or it's off. It's on or it's off. And when that translates, we end up with different kinds of outputs. And you can already kind of get an idea yourself where analog might be a really good thing, or maybe there's some disadvantages. Whereas digital, there could be some good things or some disadvantages. There are good and both to both different kinds. And that's kind of one of the big arguments of our modern technological age, is looking at which is better, analog or digital.